section on inferential statistics, and I know that I have to cover that remaining probability concepts that also will be covered in this class. Those are really easy if we understand this prior concepts. I told right in the last class you should know the prior concepts. Then those concepts are really easy to understand. I will try to explain that along with the data set and some problem statements, so that it will be really like a practical thing will be covered. Okay, I mean in like how to use them in reality also will be covered. For that, I'm using this data set. Okay, I'm using this data set. This data set is simply like household data set. There are a lot of rows are there. If you want to do some data analysis, okay, core data analysis, I will share this data set with you. You can try here. You can see you will have some null values. You can replace them that null values with some effective value, and also you can do some kind of analysis or plotting. Different columns are there. Okay, you can convert one the here you can see the sale type. The sale type, if you see, the sale type is having some different types are there, right? These types you can convert into numbers. How to convert into numbers? You can say the sale type COD means cash on delivery, right? So COD means zero. You only derive a dictionary and then replace the values with this. Okay, for example, you define COD is 0, CON is 1, and CONLD is 2. Likewise, you define one dictionary and replace wherever you try that function using Python. Okay, wherever the value is COD, it has to replace it with a 0. In that way, you can do the data mapping. Anyway, that concept I will explain in tomorrow. Such concepts will be covered. The data pre-processing, data feature engineering, such concepts going to cover tomorrow. If you are interested, you can do it today itself if you have time. Okay. So likewise, this data set anyway I will provide you, and you can do many experiments. Here you can see many null values are there for you. You can replace them with some suitable values. You research yourself. Okay, how to replace a null value? I already told you. There are some good ways to impute. Whether you can follow to impute the null values by their mean or median. Some strategies are there. Along with that, some domain related things also we can replace. You have to identify what exact value I can replace here to help me. There are some other things, something like forward fill, backward fill, and also filling with a suitable value or zero. Sometimes we fill zero, or sometimes we fill with mode value. Mode is, right, most repeated value in the column. Likewise, you can do many pre-processing steps here. Okay. Now let's get back to our statistics part. In this session, what we are going to learn is a new library also going to introduce to you, that is called DABL. That library is simply we will use it for, a few people use this. That is why I wanted you to learn this also. You can see what is this DABL. DABL library is simply, it is a Python tool for data analysis we use, and for also ML automation purpose also. People use DABL, but very rarely you see this library. But anyway, it is an added advantage if you have. Uh, it is simply we can install that library and then we can start using it. Here you can see clean we can do automatically. Many machine learning steps can be automated this. But if you use directly DABL, you will not get that flavor of doing analysis because it is doing automatically. That is why, practice the traditional ways, and also if you want to practice the automated things, you can also use DABL. There are some other automated libraries also there. I will tell at the end, maybe. Please remind me at the end of the course. That time I will share the automated libraries are there that I will share, because if I share now, means you will miss the real traditional way of doing analysis. It will do automatically means definitely many skills you will not get. The approach you will not get. That is why I am not deep diving this library. But this library is also there to do direct plotting. Here you can see, just I have provided. See, you know how to read the data set. I have already told you. And here I'm just doing a plot of the entire data set. I just provided the entire data set. I'm just mentioning what is the target column. Target column is simply where which column we are really doing analysis more. Okay, in machine learning, we will discuss more about this target column. Here, the target column is sales price of the sale. Okay, sale price. If we pass the target column, automatically you can see the plotting is done. Okay, if I don't use this one plt dot show, you can even see all mathematics also it will calculate it. It will take anyway some time because these are all automated libraries, automation related libraries. So it will do auto checks, auto many internal functionalities it has to undergo and then plot. Here you can see, showing all the 10 categories, 44 categorical features it showed, and many things actually here. Okay, it showed, and then target distribution is also it identified it is a continuous one, so it is distributed also sale price according to its frequency. This is histogram. Automatically it took the histogram, and then it automatically did the what is that uh, we call it as pair plot, right? I already explained you pair plot. Automatically took the pair plot of the best features, and also hue parameters wherever applicable it automatically given itself, and violent plots also, not violent, strip plots also it is plotted wherever it required. Box plots also plotted. You can see all automated things. So with one library, one function, you get all required things. But if you learn directly automation thing, definitely you will miss the real flavor of analysis. That is why practice the real traditional way. Then you can automate the things using making use of automation libraries. Then you will be understanding, and you will also know why we are doing these things here. Okay, we know that we will use the box plots for getting to know whether there are any outliers or not, or all such things, right? Here you can see how easily it is automatically plotted, and then letting us know what are the columns which are having the outliers and all. So these are some automated libraries also there. Okay. Okay. So basic probability, anyway, I discussed. I'm not going to touch more, but anyway, I provided you a basic example. Please refer this. Today I will share this so that you can refer easily. And here you can see the probability formula, and where there are two probabilities, sorry, two events are doing A and B. If there is any condition, there is at least one occurrence is, then that is what sum. We will do the sum of their individual probabilities, and then minus the probability of their intersection. Okay, remember this concept. This is called mutual exclusive concept. I mean, prob you have to understand mutual exclusive is nothing but when there are two events going to happen, A and B. Two events are going to happen, and there you wanted to know at least one occurrence. Okay, then mutual exclusive concept is comes into picture. That is what you should remember, and your mind has to tell in the right time. And formula, of course, you should remember as a graduate student, and also as a computer science student, you have to know the implementation using Python. But these two things can be get. What my point is, in reality, to be frank with you, it can be available in Google and ChatGPT, or some of the AI tools can give us. But you have to know this concept prior, and you have to validate your results with the reality, and then only you confirm it. Because today, I mean, today means these days, whatever you are getting out of internet or ChatGPT, you cannot trust completely, because that concept was not known to you earlier. In that situation, you have to refer to the core things, either textbooks or reference materials or paper publications. You have to refer and then confirm. Don't go and take straight away the results of such AI produced ones. That is what my point I would like to cover. Here you can see the simple thing. We are anyway having a neighborhood column is there in our data set. Neighborhood column is there. Where is that? There are a lot of columns are there. Uh, where is that? Where is that? Okay, Control F we will do. Neighborhood, Neighbour. Array. Okay, no problem. We will find it from here only because we know how to do it in pandas. Data of neighborhood, NEIC, neighborhood column is there, right? If you observe the data point, these are the data points are there. I mean to say some column CR. I too don't know what exact. Maybe these are the neighbors of neighbor names, maybe. Okay, so if you see value underscore count is such a function, you will get all the values, different categorical values inside that particular column with their frequency count. Okay, how many of calls CR are there? Old Town, Edwards, Somerset, and Gilbert, all such things count also will be given to you, right? So these like this is the way how you will get the frequency related things. Okay, and if you want to know the the spread. Okay, uh, spread is nothing but, see, 225 is one value, 150 is one value, 113 is one value, 100 is one value, 86 is one value, so that you will get to know more values are from names, and some information is being carried out, right? Such informations is what that numerical things is what you are getting is what can be called as analysis. That analysis can be done in many ways. Either you can use statistics or probability anyway. Okay, and one more thing we can see, how if we want to know total number of houses in the neighborhood, like simply shape. Shape will give you two parameters. One is rows information, another one is column information. If you want to get the first thing, then that is what rows. Okay, you understand what the number of rows defining as the number of houses. Okay, if they ask you how many number of houses are there, then simply you have to understand, okay, if the data set depicts as number of rows is nothing but number of houses, we can get it by using shape parameter itself, shape attribute itself. Then any old town, if they are asking, any stakeholder asking any old town. Okay, so Mushraf asked me in the beginning of this session, how do we define an approach is good or not? And here the stakeholder question is this, okay, old total number of houses in old town neighborhood. So the question you have to understand very clearly. Here, some data point is very clear and column name is very clear. So you have to identify whether that column is there or not. First thing. If it is yes, you have to check whether this value is there or not. If these two are there, you have to understand how to get that value. Then the approach is, first of all, we have to figure it out where exactly the data column is there. Then we have to again equivalent, I mean equal to check we have to do with the data point. Data point is old town. We have to do equality check with the data point so that we will get all the related values. In that, we know that shape defines as rows and columns. Rows define as number of houses. So if I can get the values out of this and then do the shape and then get the rows information, that is what number of houses in, especially in old town neighborhood. So this is what the approach. Got it? Is it clear, Mushraf? How the approach is actually in real time? Oh, Mushraf left. Okay, no problem. And probability. Let us find the probability. For example, picking a house in Old Town. Okay, picking a house in Old Town means, first of all you should know how many like favorable outcomes houses in Old Town, and then divided by total number of houses. Then you will into 100 will give you the probability. See, Old Town, just now we discussed how many favorable got 113. Total there are 1460. The 113 by 1460 will give you some 0.7, and if you make multiplication with 100, that will give you the probability. That means 7.74 percentage of chance is there to pick a house in Old Town. Is this clear? Real practical thing where in what way you can implement the simple probability things. Then we will understand about conditional probability. Conditional probability is always depend on two things. One is multiplication, and another one is addition way. I will explain you where you have to I mean in what way you can calculate in the best way. So first of all, let us understand this question. There are 10 candies are there in a bag. 5 candies are green, 5 candies are blue. Then the question is, what is the probability of getting 3 candies blue candies in a row. If I pick three randomly, all such three should be blue. Actually, there are five blues. Out of five, I want three. Three should be blue back to backly. That is what the probability. Here, back to back, and is there, right? One and one and one. In that case, first of all, you have to understand. Let us consider one candy picked, and that is what blue we are expecting. What is the probability of one candy that should be blue? That is one upon. You can see here, like five blues are there. 5 divided by 10 is what you will get a candy to be blue. That is what the probability is 1 by 2. And then second candy also you are expecting. One candy you already picked. So total there are not 10. There are only 9. Out of this 9, you are expecting one to be, blue. So we first one we anyway calculated the first one is already blue. Then again 5 minus 4 also we should do. Sorry, 5 minus 1, 4. So 4 divided by 9. That is what the second candy to be blue. Third candy again. Third candy means now we have only 4 blues. Out of 4 we have to subtract 1. Then 3, 3 by 8. So if you multiply these three, then 0.08 will be given getting. Means only 8%, not even 0.08 means into 100. If you get 8%, 8% chance only. If you pick three candies simultaneously, there are one by one, there are blue. Okay, 8.3 chance. Yeah. So here you have to understand whenever you are doing end operation, simply end operation means you have to multiply the probabilities. If you are doing OR, okay, OR, then OR means this or this either green or blue. Such type of things if you are getting, yeah, so you have to use OR means addition. You have to add the probabilities. Okay, so these things are basic things actually. These are called as conditional probabilities. Okay, another question is given. Okay, given that we have the probability of picking a house in old town neighborhood, we go to a step further and again pick a house from the same neighborhood. So that is what the question. Given that there is a probability that picking is old town neighborhood already we got the calculation that is 7.74 percentage. Again we are going to pick a house that is again from the same neighborhood. What is the probability? Then here you can see conditioning. Houses in Old Town we know divided by all houses also. This is what 7.73. Now we are multiplying with houses in Old Town minus 1 divided by all houses minus 1 because already one is there. And we are here clearly mentioning one we are doing and another one we are performing. So then multiplication is what we require. So Submarine asked me, so we anyway have the direct functions in majority in probability or statistics. Yes, we do have majority of the functions are available, but also you should know the concept so that you will apply such things in reality. Is it clear, Submarine?
Yashwant.
Yeah, so that is why you also, of course, 90% we use, as Samrin told correctly, 90% we use functions only, but sometimes, according to the question, we also have to use the core concept. Sometimes like this addition that or plus. In this question, if they're same question, but if the question if we modify, for example, old town or any other, then in that case, then we can go for plus and we are doing this and then the next one is also same. That is why we are using multiplication. Okay, so here you can see the conditional probability that is around 0.5 means here we should also do this in the same line, then we will get the 100%. Okay, neighborhood is just 59 percentage only. Okay, 59, sorry, not even 59, sorry, 5.9 into 100, whatever it may be. So this is what conditional probability, and here it did not did correctly. Let me do correctly. This Google Colab actually some as Python version is getting improving, it simply sometimes don't perform. I mean, The old version thinks correctly. Here you can see, now you will get it is 0.5 only, even after into 100. Okay. So very less chance. Okay. Anyway, second thing is, dice type of problems. Okay. Dice type of problems means, if you have six, if you have two dice, okay, then if you are rolling it, there are total combinations are 36. Correct? If two have two, you are having two dice. Each dice is having six combinations. Another dice is having six combinations. Total, if you do total, then six times of six, 36 combination. I mean to say, if you roll two dice simultaneously, one die on top of one die, you will have one. Another die may have one. In that in that use case, we can fix one die one side, and we can alter the iterate the second die. So in this way we will have 6 into 6, 36 combinations. And the probabilities are like this: if you want to get sum as 2, okay, then the probability is 1 by 36. If we get sum as 3, these are the possibilities are there, then 2 by 36. So why I provided this dice problem is, sometimes you have to do, you know you have to solve probabilities when there are combinations are more. Then you don't have to confuse how to calculate the probability correctly. So here you can see, if the probability, what is the probability of getting sum as a 3 on both sides of two dices when they simultaneously rolled. So then their combinations are only two. First dice may have one on top, second dice may have two. If reverse is also possible, first dice may have two on top, second dice may have one. Other than these two combinations, there is no other way to get sum as 3. That is why two combinations are available out of 36 combinations. That is why the probability is 2 by 36. So don't confuse, such type of things also may come in reality also. So you have to understand the combinations clearly. Then PDF PMF function, anyway, this was been discussing from the last 2 days. Simple, again I am telling you, PDF means it will come when there is discrete random variable. PMF, okay, sorry, PMF is what, discrete random variable. And PDF density, anyway you can understand this is very easily. Density means continuous, okay. So that is why PDF is probability density function is always suited for continuous variable, okay. And normal distribution, yes, this is the concept. Normal distribution is simply, here you can understand the normal distribution. It is a histogram with KDE. KDE is nothing but this line is called KDE. Okay. Here you can see it started with 0 and ended with somewhere around 80,000. I mean 8 lakhs maybe. Where exactly mean, if you calculate the mean out of this, then I will show you the mean also. Data of sales price is what we are doing, right? You can calculate mean by using like this. Dot mean, simply print. Same line we print, but with medium. Okay. So you can see mean is somewhere around like this. Median is this. Whenever your mean and median both are equal, and that is what normally distributed. But this is not normally distributed. This is a skew. Where exactly data got allocated, left side or right side? Left side. That is why it is called left skewed. If data is accumulated at the right side, then it is called right skewed. Okay. So that is what, skewness can be also determined by using histogram with KDE factor. And whenever your mean and median both are equal, here observe this one, you can observe this one. Whenever your mean and median and mode both are equal, 1.4, here you can observe. Understand this concept clearly. If not understand, please let me know. I am ready to repeat it again and again. If you see this one carefully, here it is a perfectly normal distributed. Why I am telling this is a normal distributed means where my mean of this data is equal to median of the data and also equal to mode of the data. That is why I can say this is normally distributed. If we have the normally distributed, then what is the benefit is 90 per, if there is any question given to you, like 90 percentage of the data or students of school are between 1.1 meter and 1.7 meters, we will have the estimations, right? In reality also, we will say that 95% of the students will pass this examination with these marks. That means 95% will determine always, um, uh, according to Euclidean formula. Yesterday I told you, right? I will also have a picture to show that. Yeah, this is what. Okay, here you can see 95 percentage of the data can be determined with the help of a mean plus standard deviation. Okay, mean plus standard deviation. Let me take a paint and explain you. If your data is normally distributed, what is the benefit is? What is the benefit is you can get the estimated values and you can plot that range. For example, this is divided into three parts. Okay. First part is 66.7, nearly 70, 67 percentage. Your 67 percentage of the spread belongs to mean plus 1 times of standard deviation. If you know these are the data points, okay, the data points can be 1.1, 1.3, 1.4, 1.5. These are the data points. If you consider these are the data points, if you calculate the mean out of these, this is what new. And also if you calculate the median, that is what you will get as median. If these two are equal, then we can consider this is a normally distributed data. If this is a normally distributed data, you know how to calculate variance, sigma square. Out of variance, you know how to calculate standard deviation. Saturday, I described about how to calculate a variance and how to calculate standard deviation. The straight away functions are there. In Python also straight away functions are there. In mathematics also direct formulas will be there. If you know the standard deviation out of this data, if you do this sum, nu plus 1 times of standard deviation, that will be definite. This is the mean. Okay. Let me take mean as a long line. Okay. This is the mean. Nu plus 1 times of standard deviation will be here. And mu plus 1 times of standard deviation will be here. Nu minus 1 times of standard deviation point will be here. That means from this to this point, 67 percentage of the data will be available. Okay, got it? And if you take 2 times of standard deviation, then from this point to this point will be covered. And that range is very big range. That is 95 percentage of the data. And what about these extreme points? Yellow, you can see the yellow points. This is nothing but 99.9 percentage. That is nu plus nu minus 3 sigma here. Here nu plus 3 sigma here. Got it? So using this normal distribution, we can get the data ranges, whatever we want. Is my point clear? Is my point clear? What is the normal distribution? Is that clear? This is not the normal distribution because the mean is this much. This is what. Then what is this? This is left skewed. If some points you may see, this is what? Right skewed. Here you can see left skewed versus right skewed. Left skewed distribution versus right skewed. Go to the images. See here you can see. Okay. Okay. So where exactly the data point? So that was according to my like my left and right, but according to the screen, if we see, like where exactly the data points get allocated from the mirror point. Okay, if we take the mirror point, then it is left. If we draw the line here, mean, it is right to the right side of the mean, right? But according to the I'm like screen way, it will be left. You can observe according to the screen point of view, it will be left. Then we can say it is a left skewed and it is a right skewed. So, okay, I told wrongly here, right skewed it is. Okay, in that case, it is right. Okay, so you can say left skewed versus right skewed. These are not perfectly skewed. Then how will we get the perfect results? I told that we will get the perfect results using normal distribution. Then you can apply a log. Then you can apply a logarithmic function out of this. Then you will get the normal distribution. This skewedness will be removed and we'll get the normal distribution so that we can estimate the spread of the data. Is this point clear? Is this point clear? Can I get a quick confirmation? Because this is very important. Is this
Yes,
clear?
Yashwant.
What about you, Praswal? Is this clear?
Yes.
Good, good. So don't confuse that. Okay, then there is second concept is what? Standard normal distribution. Okay, and one more topic I told you, right? Standard normal distribution. What is that concept? Standard normal distribution is simply we will apply a G score. Okay, so let me show you one more thing. Standard normal distribution is simply we will normalize the values. We will normalize the values. So earlier we do have different values. Here 1.1 m is there meters. Here, you can see this example. You can see this example. Let me show you this example. This example is having 95% of the data between 1.1 meters and 1.7 meters. But when it comes to the normal distribution, for simplicity, what we will do is we will convert all these 1.1, 1.2 values into normalized values. In normalized values, simply we will do mean value should be equal to 0 and standard deviation will be equal to 1. Okay. Earlier, we don't know the standard deviation of it. Earlier, I provided you the simply the formula. Nu plus 1 times of standard deviation. Here, the standard deviation, how it is calculated, you have to get the calculation out of these points. Okay. Earlier, we don't know the standard deviation. Now, what we are doing, we are estimating the standard deviation to be 1. Okay, here we are making it as 1. How can we do this? Is z score will actually tell us x minus mu divided by standard deviation. Okay, here mu value will be 0, and so that you will get the standard making the mu value 0 and the standard deviation is equal to 1, and ultimately you will get the standard normal distribution, and the standard normal distribution will be like this. Okay, here you can see will be like this, where here mean will be 0 and standard deviation will be 1. So nu plus 1, you know that nu plus 1 is what? 68, 67 percentage. Nu minus 1 to nu plus 1 will be get 67 percentage of the data. And this is why we are doing this is we are just standardizing all the values to the constant unit. Okay, so sometimes we have to perform standard normal distribution, and and this is what normal distribution. If we make mean is equal to 0 and standard deviation is equal to 1, that is what standard normal distribution. Okay, and log normal distribution I already explained you, if in order to remove the skewness. Okay, sometimes we do require, sometimes we keep it as it is. Okay. It is not mandatory that every time you should apply log normal to the skewed data. It is again, I told you, right? Sometimes the stakeholders may not accept you to do some changes on top of their data sets. Okay. Let's come to the inference topic. Inference, statistical inference. Okay. Allow me to 1 minute. I will be back with charger. Yeah. Okay, so now we are going to understand about inference. Inference statistics is simply, uh, the difference between inference and the real statistics is statistics apply on population, inference mostly apply on sample data. There are two things, sample and population. Population is simply, let me take one more thing. See, population is the whole US, let us consider, our whole Indian people. These are population. I wanted to know the average income of an individual in India. You might have seen some statistics, right? In reality, average per capita income and average child ratio, average male ratio versus female ratio of India or US or Britain, and average educated or literature ratio. And in India, do you know which state has highest literature ratio? Any guess?
It's Kerala.
Exactly right, Kerala. So how do they define such values? Okay, so it is very difficult, right? Go to every door because it is 140 crores, I guess, population of India. I mean, this is my guess. I don't know the exact sharp number. 140 crores people. It is very difficult to go and ask every individual whether you are educated or not. Whether it is very difficult. And in order to make simplicity estimated values, anyway, the average is what estimated value. It is not. It may not be the perfect value which will suits to everyone, but it will give us a clear cut idea or estimation. Okay, this is what can happen, or this is what may be the result, something like that, right? So in order to get that estimated results out of the entire Kerala, for example, let us consider only Kerala. Kerala itself may have at least 7 crores population. It is very difficult, even though going to everyone, because it will take around 1 plus year, right, to calculate everyone. I mean, to go and every individual to get that, because some individual may travel in train or flight or maybe anywhere, or some individual may expect to some other countries. So it is very difficult to get their information. Then what is an alternative? We can instead go and take the samples. So let us consider in Andhra Pradesh, there are 10 districts are there. Okay, 10 districts. So every district, there are many, again, mandals are there. And every mandal, there are cities or places are there. Okay, somebody has joined. Huh? Okay, must have joined. Okay, so it is very difficult to go, right? So in that case, we will collect the samples. We will collect the samples. So this is what the population, and this is what the sample. The sample out of this population. You can collect n number of samples also out of the population. Okay, that is okay. But what we will do is we will calculate the statistics on of these samples, and based on these statistics, we will estimate the entire population values. Is this clear? The difference between sample and population? We have to do such a way, we have to collect the sample points in such a way, those estimated values definitely should meet the closest values of the entire population. So these sample details only we will share it with the government official sites. That values only we will keep on listening. Okay, is that clear? Samples and population, is that clear?
Yes, Ashwin.
Here you can see, let us consider 500 houses are there randomly from 1460 houses. 500 is a sample, 1460 is what? Population. Okay, these are very important concepts, population and sample. Here, random dot choice, anyway, I told you, choice means nothing but out of your desired values, it will take choice, any. Choice means any, randomly. How many you want, that is what size we have to mention. Sale price is what the data point we already see. Let me take again sale price, uh, data of sale price. So these are the data points, normal sale condition. This is sale price, we want sale price. I shocked why it is normal enough. Okay, these are the sale price values. I want 500 random values because there are 1460 total rows are there, total houses. I want 500 houses. Sample, random, any. Random, here we use a lot random. Then what is the seed? Seed defines whatever the values, random values I am getting. If you use the same seed, you will also get the same type of randomness. That means to say, same means every time I run, random means you know that, right? Random is every time I run it, we will get different values. For example, if I use this one, np.random dot choice. Okay. So A is equal to 1, 2, 3, 4, 5, 6. Okay. Size, let us notify what we will get. 6 now. If I fix the random seed as 42, okay, observe 4, 4. No matter how many times you run, every time it will take the same random value. Is that clear? Why this seed helps us? Is that clear? Why this seed is very important? Okay. So then the seed we are now fixing a 6. Any value you can take the seed. It is not the big matter. Simply many times data scientists use 42. Okay. So there is actually fun story is there. Story behind. You can go ahead if you are interested. Story behind random state, random state, state is 42. 42. Okay. Some Douglas Adams, some story behind there. It is not very much important, but it's a good story. You can also go through this concept 42. Many times, if you see the code of machine learning, you can see random state is 42. Okay. The reason, I mean, there is not a reason. This is not a reason. You can mention any random state that is of your choice, but there was a story behind it. You can go to. Okay. Here what I'm getting is random samples. I'm 500 random samples out of this data point I'm taking as a sample. I'm calculating the sample mean. I'm calculating the population mean. Population means the overall mean. So what values I'm getting? The here the sample mean is, you can see 1800, sorry, 180,091. Here 180,922. So very close, right? Sample mean and population mean is very close. If the data points are very well organized, here, though the data is perfectly, you know, perfectly normalized, but here the data points mostly got stopped here. Okay, so mostly stopped here. So it is left skewed. Not left skewed. I also many times confused. It is the data is like this means here it is right skewed. Okay, it is right skewed. So here we can see it is a right skew, but the data points are actually allocated more like this. And the average here we are anyway calculated 180,921. If we take 500 random points, yeah, that is also following the same strategy. Um, getting the most equivalent rand like mean. Are you guys observing this one? Our sample mean is somewhat equal to the population mean. That means if we do the right analysis on sample data, we can estimate that results with the population data. Clear? Okay. So then statistical inference is all about, it is a subset of the population. We take the subset of the population, that is what we call it as sample data. We carry out some tests on sample. We carry out some tests to gain some insight on larger population out there. Statistical inference is simply like a process of analyzing the sample data to gain the insight so that we can estimate that insight to the population. And then we will investigate. We also have to investigate the difference between different data points, and also that is also there. And that is a theory about statistical inference. And all the steps what we are performing now onwards are all are a part of statistical inference. Okay. First thing is central limit theorem. Central limit theorem is, you might have heard about it earlier in statistical topic. It is simply, it is, like, for example, it is a statistical theory that states that given a sufficient large sample size from a population, sufficient. Here we took 500, right? That is a sufficient size. Likewise, if you have a sufficient large size sample size from a population with a finite level of variance, mean, all such things, we here it is important, will be approximately equal to the mean of the population. Furthermore, all of the sample values will follow an approximate normal distribution pattern. That means if you take sample points, enough sample points from the population, if you go and calculate the mean and variance and normal distribution, approximately you will get all such sample points distribution is normal distribution pattern only. Okay, I will show you a small example. Here you can see a population. This is a random population. Now we are not taking the actual population. Now we are taking a random population. Here you can see some exponential mean we are taking. Okay, so exponentially increasing. That is what. Okay, size is 10,000. Big size I'm taking. And sample sizes, I would like to test a sample sizes first as 5, second as 10 samples out of this 10,000, and third as 30, fourth as 50. You can see the end result. This is what an exponential data, right? Earlier we have seen the right skewed data. Similarly, it is also any one of the skewed exponential. And if we take 5 sample sizes and we calculate the histogram, if we plot that histogram, random 5 points out of this 10,000, if we go and plot, we will get normal distribution. 10 normal distribution, 30 normal distribution, 50 normal distribution. This is what central limit theorem explains us. Got it? According to the central limit theorem, no matter what the sizes, I mean enough sizes, again here it is very clearly mentioned, some sufficiently large sample size. Okay, if you collect that and if you go and plot, here you can see simple, it is a for loop considering one thing constant and then iterating over values. Here you can see I use the list comprehension also. Okay, so this is what site layout is one more function in the matplotlib library that will help whenever you are having multiple plots in the single graph. Then it will help you to not joining them together. It will help you to plot separate plots. That is what site layout. Okay. Yeah. This is what central limit theorem explains. Got it? Here you can see the justification in the graphs above. Yellow curve here I did not use the colors. Actually I changed color. I will remove the mean of the Gaussian. Yes, this is what important. Anyway, this is also covered that the Gaussian distribution mean is exactly same as the one that one, and it will give you this is the one square root of this is what important square root of 1 by n. That means sample population we define mu mean. Here we define x bar as mean. Sample mean is x bar. The notations will get changed. And variance also we divide square root of n. Instead of small n, we divide square root of n. Okay. The formula little bit will be differed. Okay. Second concept is confidence interval. First concept is central limit theorem. I hope it is clear to you. It is simply, it will explain, this theorem will explain you. If you take the random samples out of the population thing, you will get all the time normal distribution, no matter what the distribution of the population earlier. This is what some central limit theorem. Confidence interval is very, very important to understand. Confidence interval is, they will say the chance, right? Here you can see 50, 95% of the chance. They will say confidence interval. Some interval has to be defined based on the percentage. For example, you have a distribution. You have a distribution. This is what the distribution you can see. This is what the distribution. You have the distribution like this. Okay. You wanted to know 95% of the data distributed from where to where. Okay. 95% of the data got distributed from where to where. Then you can use this confidence interval 95 percentage. Okay. 95 percentage minus 100 percentage. How much we will get? 5 percentage. 5 percentage means 0.05 percentage means divided by 100 only, right? If we do that, that is what 0.05. That value is very important. I will explain later on. But here the confidence interval will help us to get the estimate at lower limit and upper limit. Okay, 95 percentage they are estimating means we have to do calculate. We have to consider if the data distribution is normal distribution, then our mean value we will anyway will get. We will also will get the standard deviation. 95 percentage means nu plus 2 times of standard deviation. If we calculate that, that is what we will get. Let us say 5.62 as upper limit, and nu minus 2 times of standard deviation, we will get the lower limit. That is what we can estimate it as 2.92. So the data points can get, see, can have 2.92 to 5.62 estimated range of 95 percentage of the data. Remaining 2.5 percentage, 2.5 percentage are outliers considering. But it is an estimated computed from the statistics of the observed data. This purpose of range is like unknown parameters, we will get the estimated interval. Okay. So whenever the stakeholders is asking you, I wanted to know the 95 percentage of the data spread from where to where, or 67 percentage of the data getting spread from where to where. I wanted to know. Then you can easily calculate using this confidence interval concept. Okay, assuming your your thing is in normal distribution. If not in normal distribution, you can seek, like you can research whether you can alter this to log normal according to your domain. Okay, if you are doing log normal, is there any big change comes into your domain? Because sometimes it also respect to the domain. Log normal you can apply so that it will compute you to the normal distribution, and then you can implement this confidence interval concept. Here you can see the simple thing. Okay, and one more thing, you have to know the G statistics. That is what G score. G statistics, actually there is a table existing. This is what the table. Okay, so here you can have the negative values of Z and also positive values of Z. Up to 3.4 you can see positive, from negative minus 3.4 to positive 3.4. You can calculate the Z statistic value. Okay, normalization, ppf. Okay, then you can mention 95 percentage means 95, and whatever the percentage, like 95 percentage data or 65 percentage, you can mention that, so that you will get the Z critical value, right? You can see the Z critical value is here 1.64. You can also go to the, you know, G score table and search for Z value as 1.6. Where is 1.6? Here it is 1.6. Okay, here it is 1.6, and the confidence interval is 95. 95 means there is 0.05, right? I told you remaining percentage is 0.5 percentage, that means 0.05. Here our case is 1.6 and 0.04. Here you can see 0.95. Is that clear? That mean to say, you can see based on your Z critical, you will also get the you know, based on your Z critical, you will also get the estimated confidence interval. This concept is, see, here you can see, by using mathematics or straight away mathematical or Python functions, okay, library functions, you are directly getting, you are just passing the value, you are getting the Z critical. But earlier days, earlier mathematicians used to calculate the Z critical using this table. That is what my point. Okay, earlier, so your percentage, if your percentage is 0.95, they literally go and check where exactly 0.95 is existing. Okay, here you can see 0.95 is existing. Since I directly know that it is there in 0.05, because this is a common example we directly use to explain this concept. I know that it is there. That is why directly I guided you. Otherwise, what is the process is, we have to identify where exactly it is in the table, and then according to its Z critical value, they will explain. Okay, but now we have direct functions, you need not to worry. Directly you can use this function called stats.norm.ppf and mention your percentage, so that you will get the Z critical value. Okay, and confidence interval is, you know that, you mean minus margin of error, and mean plus margin of error is what confidence interval will get. What is this margin of error? There is a formula existing. So like Z critical multiplied by, multiplied into, here anyway standard deviation we know, right? So population standard deviation divided by square root of, we have to do. Here there is a small variation in the formulation. So with the respect to the Z critical, this is what we have to implement. Remember one thing, whenever you wanted to find the confidence of interval, let me explain you this concept again. This is very important. If you are doing some analysis where the stakeholder really wanted to know the 95 percentage or any percentage of the data, then you have to calculate the lower limit and upper limit, right? So where exactly the data got spread between these two. So this concept is also applicable in reality. For example, gate examination or AIEEE or MSET examination you have given. Then not MSET examination, gate examination or CAT examination, GMAT examination you have given. So 95 percentile you have to get. 95 percentile means uh, you will get how they calculate is they will they will first list down what is the top score. Okay, what is the top score? Second top score, third top score, fourth top score. All the top scores they will literally write down. Out of 90 marks, let us say 65 marks is what the top score. 65 top, 63 second top. Likewise, they will sort in descending order, and then they will calculate 95 percentage. 95 percentage means they will take 95 means here they will pass the 95 here so that they will get the G critical, and then they will get the G critical, right? The G critical into, since it is a population, because we are going to do the analysis on the every individual. Let us say 1500 students has given the gate examination. We need all the 1500 students. That's why we do calculate the standard deviation from the population and then divided by square root of the sample size. In earlier we use direct n, but here we have to use square root of n. Okay, so we have, this is a formulation actually. So why square root of n? Why not normal n? Because mathematicians defined that this is the best way to get the margin of error. They have done lot of researches and all, and they finally confirmed margin of error can be calculated effectively using this formula, Z critical into population standard deviation divided by square root of sample size, so that you will get the margin of error. If you get the margin of error, then confidence interval will be sample mean minus margin of error, comma sample mean plus margin of error. So that you will get the confidence interval, the two limits you will get. Okay. So whoever passed in that, I mean, whoever scored in that region, that person considered as 95 percentile, and then admissions uh, can be defined. Okay. So this is the way how you can define the confidence interval. Then hypothesis testing is the second next topic in inferential statistics. That is what hypothesis testing. Hypothesis testing is there are two types of testings. One is null hypothesis and alternate hypothesis. Null hypothesis is something like we will define a statement, general statement or default thing. If that is true, whatever we define, if we get the same result out of our analysis, then null hypothesis is true. We reject the alternate hypothesis. Alternate hypothesis is if we don't get that statement and if we get the something else result, then we have to reject the null hypothesis and accept the alternate hypothesis. Okay, simply. I will let you understand in simple terms. In simple terms, let me consider a small condition. Our sample mean, we will get one sample mean, and we will also have the population mean, correct? We will have the sample mean, we will have the sample mean, we will have the sample mean. So this is what sample mean, x bar, and this is what population mean, nu. I will say a statement. I will say a statement. Sample mean and population mean both are equal, and then you have to calculate this and calculate the sample mean and calculate the population mean and test whether they are really equal or not. If they are equal, whatever I stated, that is what null hypothesis. If they are really equal, then null hypothesis is true. If they are not equal, if we are getting different results other than equality property, then we will say null hypothesis is wrong, accept the alternate hypothesis. Alternate hypothesis is what true. This is simply a statement. I already told, right? Statistical inference is simply we will define. Here you can see, statistical difference is inference is we get the insights from into the population. In order to get the insight based on the sample data, if we want to redirect with the population, we have to undergo some investigation. That investigation is what hypothesis. Is that point clear? What exactly hypothesis? In order to do that, there are two things. Here also the statement. In inference statistics, the null hypothesis is a general statement or a default position that there is no relation between two measured phenomena or no association among groups. That is what null hypothesis. Statistical hypothesis tests are based on statements called the null hypothesis that assumes nothing interesting is going between whatever variables you are testing. Therefore, null hypothesis would be mean of the, let us consider this is an example. Mean of the house prices in Old Town is not different from the houses of other neighborhoods. This is what the statement I made. Okay, if this is really true, then null hypothesis is what true. If not, then alternate hypothesis is what true. Don't confuse. But may I know whether this point is clear? The difference between null hypothesis and alternate hypothesis. Is it clear? Can I get a quick confirmation? Can I get a quick confirmation?
Yes.
Very good, Prajwal. What about summary, Mustafa? It is clear? Can I get yes? I mean, shall I?
Yeah, yes, Ashwant.
Good, good. So don't confuse. It is a confusion topic only. But if you understand two to three times, if you repeat yourself, then you will get to know what exactly the difference between null and alternate. And in order to tell null hypothesis is true or alternate hypothesis is true, what value is really helpful to do? I mean, to help us to estimate. That value is called p-value. So in statistical hypothesis, the p-value, it is also called as probability value, is simply it is a probability of obtaining test results at least as extreme as results accurate actually observed. This is what the statement. But simply we will define one p-value. Okay, significantly it is 0.05. That means if we see a p-value lesser than 0.05, then here note this point, then we reject our null hypothesis. We reject our null hypothesis and accept the alternate hypothesis to be true. That means we will do some calculation. I will show you that calculation practically. In our calculation, let us say our p-value is less than 0.05. That means whatever the statement we stated in the earlier, that will be wrong and alternate hypothesis will be right. Here you can see we reject our null hypothesis. If we see lesser than 0.05, then we reject our null hypothesis and accept the alternate hypothesis to be true. So let us consider the small thing. Z statistics and p value. Z statistics earlier I showed you small function, right? Norm dot ppf. That is what Z statistics way. Another way is both the things, Z statistics and p value. If you want both values at a time, then stat model is one library is there. Inside that weight stats and then Z test, especially Z test is a function is available. If you use that function directly, you will get both values. Okay. So Z statistics comma p value. You just need to pass the condition. Here the condition is uh, old town old town in neighborhood we would like to check the mean and it is not different from the houses of other neighborhoods. That means here simply you can understand I what I really want to check is mean of this one is not difference means it is same. It is same as houses of other neighborhoods. Old town house price and other neighborhood prices of the mean, the average price is same. That is what I am stating. I have to check whether it is really true or not. First of all, let me take that condition. Approach is first of all I have to take the condition of sale price. Okay. Here I will take the condition. Okay. Here you can see if you run this one. This is what neighborhood when it is equal to only. I will also show you the neighborhood also so that you will get a clear idea whether this condition is really working or Here I'm just writing the condition. Anyway, I told you the writing the conditions using the lock function, right? You can also do without lock function also just by passing the data frame. Okay, let me show you lock only because this was already told you. You can stick to this one, data.lock. Here you can see I'm checking neighborhood equal to old town. These are all old town values. There are nearly 113 values are there, and sale prices are of this old town. I wanted to know the mean value. Here you can see average. Average means mean, right? Uh, where is that functionality? Here only. Yeah. I am taking the value of sale price of mean. Okay. I'm just checking that this condition, whatever I'm getting, the mean value is same as the mean of other values. Okay. That is what I'm checking out. In that situation, I'm calculating the p value. If my p value is less than 0.05, then null hypothesis, whatever I stated, is wrong. Alternate hypothesis is what true. Alternate hypothesis is what simply it is the opposite of null hypothesis. That is, mean of the house prices in old town is actually different from the mean from the houses of other neighborhood. Is that clear? So now you can see using the small function, stating your original condition and then passing the value. Value here is simply we are checking with the mean values of the sale price. So that is what the value. Then you can get the results. Here the G statistics is minus 0.63. Earlier people used to do using table. Earlier people used to do using table. In exams they used to carry the table. This is what the table minus 10.63. You can check minus 10.63 from the table minus 10. Okay, here only minus 3 up to 3 only given. Okay, no problem. Actually the table defines. Here we don't have in the table whatever I'm showing it is not having. But anyway, forget about the table. I'm just wanted to explain you. Earlier people used to do with the help of table. Okay, calculations using help of table. You might have observed in your childhood also log tables, right? It is similar to it. Okay. P value is we are getting 0.0000000019. Now tell me, is it really less than 0.05? Yes, it is. So we can reject the null value. Here you can see we can reject our null hypothesis. So the probability of getting given the distribution of houses in Old Town under the assumption that its mean is same as the mean of all houses, it is what rejecting. Okay, that we are rejecting and we are telling us it is actually uh, we are telling us not a different but it is actually different. Okay, another way, another way is also there. This is what g test or uh, this is what g test we g test you can see this null hypothesis and alternate hypothesis testing is what g test. There are two ways to do. One is g test, other one is called t test. T test is also called as students t test. Okay, Gosset's students t test is the name I mean came from scientists or researchers. There are two ways to do. Okay, one way is G test, another way is T test. When to use G test and when to use T test is whenever your sample size is greater than 30. Okay, you have to check the sample size. If your sample size is greater than 30, then you can go and apply G test. If not, then go for T test. Okay, here I am taking one more probable I mean one more hypothesis. If house prices in Stone Brook neighborhood are different from the let's also see if house house prices in Stone Brook neighborhood are different from the houses in the rest of the neighborhoods. Now I just checked. Earlier I checked clearly. Here you can see there are 113 houses are there. That means definitely it is more than 30. The sample size is more than 30. Then we consider G test. But here when I'm trying to check whether the neighborhood value count where exactly stone broke, now I'm getting only 25. 25 means less than 30. The sample size now is less than 30. If the value is less than 30, you should not go for G test. Instead, you can go for T test. How to calculate T test? In stats, we have T test one sample is the function. There you provide the same earlier, like same, but here instead of value, we have to past population mean. Okay, in the earlier function we used value, right, to provide the mean of the population. Here we provided pop mean as value. Okay, so if you provide this one, then you will get the result. Again, p value and t statistic value. This is what t table. There is one more table actually, t statistic table. T statistic table. Okay, this is another table similar to T statistics. Okay, but anyway, we need not to use the tables. We can directly get the values, right, using the functions, because mathematical functions and the libraries are very much advanced to get the direct. That's what earlier even one of our teammates also told. Directly we can use, yes. Okay, mostly 90% we use. Only 10% we use formulas in between. Okay, so directly we use this T statistics related function. I got the p value as 6 point. Don't get the conclusion immediately. Here you can see e power minus 0.6. That means 10 power minus 0.6. Then 10 power minus 6 means divided by 10, 0.000000006. That is also still less than 0.05, right? Still we are going to reject the null hypothesis. We accept the alternate hypothesis. That means this statement is also wrong. Is that clear? How to do the null hypothesis and alternate hypothesis, when to use t-test and when to use g-test. Is that clear? Can I get a quick confirmation if it is clear? Good. Thank you, Rajwal.
Yes, Session.
Yeah, very good, Mushraf. So that it is easy concept only. So you always have to, whenever this all depends on, the user question or the stakeholder question. The stakeholder will directly ask you one question. So I wanted to know the range between 95% of the range. Then immediately you have to remember it comes under confidence interval. Okay, I have to use confidence interval. I have to see first of all whether it is normally distributed or not. If it is normally distributed, very good. If not, means you have to check with the team or domain expert. Shall I use any mathematical operation to do? I mean, something like this log normal to convert it to normal and then check that thing. If they agreed, okay, you can do it on this domain, you can do it for this use case, then you can go ahead and do. And you have to analyze. If there is no stakeholder, if you are the boss or you are the team lead, let us consider, you can research on it, and then before taking any action, please do research 10 times. This is what the field. Our data science is always about research. Okay, traditional research always should be done. I already given you an example using the Venn diagrams, right? Very beginning of the our course. Data science, traditional research comes under between mathematics and domain knowledge. That is what traditional research. Okay, and then confidence interval is gone, and then the stakeholder is saying that, okay, so if I randomly choose, I mean, I have a question actually. Let us consider the stakeholder's point of view. I have a question. The mean of this one is really equal to the mean of other one. Just you wanted to test. Then immediately you have to understand, okay, it comes under null hypothesis and alternate hypothesis. Check the sample size. The sample size is, let us consider, is greater than 30. Then go and implement g-test. Okay. If the sample size is less than 30, go and implement t-test and come up with a p-value. And if the p-value according to the condition is less than 0.05, then accept that, sorry, less than means reject the null hypothesis. Whatever the statement that you are checking, that is what wrong. It may be other value. Okay. So if it is greater than 0.05, then yeah, whatever the condition that we are checking is actually true. Got it? So for example, here you can see, let me check you one thing. Definitely, I hope it will work. I'm checking out not equal to. Then you can see the z value is 0.04. 0.05 and above we are checking, of course, very close value, right? Very close value. In this case we accept the null hypothesis. Now I am checking out not equal to downtown. So now is this clear? Is this clear? Very close here. Of course, maybe the data points may have outliers. We have to also treat all of them. But anyway, we get almost close result. Is this clear? uh, how null hypothesis and alternate hypothesis works? Very good. Okay, according to the p-value. Okay. And then followed by next thing is type 1 error and type 2 error. There are two types of errors actually. These two errors also very important. In statistical hypothesis testing, type 1 error is kind of rejection of a true null hypothesis. Type 2 error is non-rejection of a false null hypothesis. What are these things? Don't worry. Here I provided you an example. Uh, for example, let us look at the trial of un, sorry, an accused criminal. For example, you are dealing a court case where there is a criminal is there. You wanted to prove him as a criminal. Okay. So the hypothesis is that person is innocent. Actually, the person is innocent. You want to prove that that person is innocent. An alternate hypothesis, let us consider, is that person is guilt, means not innocent. He is actually the culprit. Don't confuse. Now, let me repeat again this problem statement. So, we want to prove whether a person is criminal or innocent. Okay. Null hypothesis. Null hypothesis is this is what we really wanted to prove. That is, a person is innocent. Alternate hypothesis is the person is guilty. Guilty means we can say he is not an innocent. Type 1 error is, in this case, would mean that the person is not found as innocent, but he is still sent to jail. Not found as innocent and sent to jail despite actually being innocent. Is my point clear? This is what type 1 error. Type 1 error. Here, error is mistake. Okay, understand in this way. Error is simply it's a mistake. What is a type 1? Type 1 belongs to that person is guilty and sent to jail, but actually he's an innocent. In many movies also we see, right? Some innocent people goes to jail. So this is what an error. Type 1 error. Type 2 error is this is also error. Type 2 also an error. But what is this type of error? Would be a person is found innocent but does not send to a jail, but actually he is not innocent, guilty. So is this type 1, type 2 is clear? Let me know. Otherwise, I will again explain. Type 1, type 2 is clear. What about two participants? Mustafa and Samri. Is it clear? Sometimes, uh, there are, okay, Samri, it is clear to Samri. Good. I can say, I can take most of answer also. Yes. Okay.
Yeah, it's clear, bro.
Okay, good,
It's
good.
clear, sir.
Okay, it is clear means good. If not means I will explain again. There are two types of error. Both are errors. Okay. That is why we are explaining this concept errors. In hypothesis, actually, there are two things. Type 1 error and type 2 error. We have to find out if we get an error or not an error. We are anyway know that how to check the null hypothesis and alternate hypothesis. Also, we have to find out whether there is any error. Type 1 or type 2 comes into this our analysis, final analysis. So my point here, once you get the stakeholders question, you check whether the null hypothesis is true or alternate hypothesis is true. Also, you have to check if there is any error, either type 1 error or type 2 error is there. Got it? And how to check it can be based on analytical point of view. The real values you can take and the estimated values you can take. Check whether they are uh, true or not. If there are true, then it is good. If there are not true, but we are getting any error, means identify what is that error, type 1 or type 2. Okay. So next concept is chi-square test. Chi-square is actually, written as this chi. This is a symbol, Roman symbol, square of it. That is what chi-square refers to certain types of statistical hypothesis test that are valid to perform when statistics is chi-square under the null hypothesis, especially to comes under null hypothesis. It is referred to as Pearson's chi-square. There is a formula actually for Pearson's chi-square. I guess I provided here. Yeah, here it is the formula. Summation of, each observed value, O minus each observed, is referred as each observed. That means actual value minus expected value. What we got? Actual value minus expected value divided by expected value. If you summation of all such squares, that is what chi-square. Pearson's chi-square. Okay. Here if we calculate this thing for each pair of observed and expected values, then we have to do sum up. That that is what chi-square. If you do chi-square, then what will we get? It is something like it is a goodness of fit. Whether the distribution of sample categorical data matches with an expected data distribution or not. We will get that information. Okay. For example, you could use a chi-square goodness of test to check whether the race demographics of members at your church or anywhere or school or anywhere match that the entire population of your country. If you want to check with the demographics of one place with the entire population, you can use the chi-square test. Okay. And also you could use whether check whether the computer browser performance of your friends matches those of internet users as a whole. Okay. Like for example, Wi-Fi, it applicables to Wi-Fi broadband connectivity. So if your broadband is good at your home, that means you can estimate in your entire city, the broadband is really good. Okay. So I already told you, right? So the sample size we are going to estimate to the entire population. Chi-square test is one functionality. Okay. How to use this chi-square? Simply before going to that, just derive some small example that is also taken Minnesota. This example, why there is a reason. This example directly mentioned in the concept chi-square. If you see the same example being given, that is why many times we use for teaching purpose. We use the same data sets. You can also search it in Google. The same data set you will get. They consider that one. Uh, it is Minnesota. I don't know. Maybe you can relate this. Maybe some kind of. I'm sorry if I'm asking this question. Maybe racism, maybe there. That is what I felt sometimes. Kind of cases what we can witness Minnesota. Do you know this state, Minnesota? Anyone? Minnesota, where it is? I
Yeah,
think.
yeah, Ashwin, it's on the top, I think.
Is it a kind of cases getting registered top or
I don't know about that much, but like cases about them.
okay, let it be. That is that is maybe the reason I thought in the chi-square. If you search for chi-square test, so this is quite common. Chi-square test, Minnesota, Minnesota spelling it. Okay, you will find the same type of data. You will get in US. Okay, chi-square test, Minnesota. See where you can see University of Minnesota, and many times you will find same. I don't know. Okay, maybe whatever it may be, we consider the same data. Let us consider Asian people are this much, black people are this much. I don't know this to be frank. Hispanic and others and white. Okay, this is national wise, but in Minnesota, these are the results. Asians are this much, black are this much, and Hispanic are this much, others are this much, and white are this much. We are now trying to do estimate with the Minnesota with the national values. Cross tab anyway, I told you, if you remember, this is simply a frequency mapper. We will take the frequency of uh, you know respective values, but make sure both values should be categorical. That means it should be discrete. Okay, of course, we have discrete values. These are also discrete. Okay, cross tab is simply finding of count. Here we can mention count. Count means by default count only. You need not to mention. If you don't mention count also, you will get the count. Discrete value count you will get. Okay, fine. We will see the chi-square test. The chi-square means first of all we are now doing the length, getting the population ratio. National table divided by length, we will get the count, and then expected value is national ratios into length of Minnesota, get the expected count. Now chi-square is observed value. Observed with Minnesota table is what observed. Every value in observed, that is what observed. Minus expected. Expected is simply like national ratio into length of Minnesota. Okay, whole square, right? Expected whole square divided by expected. And then we have to do the summation. That is what doing the sum. And then if we print that, we will get 18. Okay, we will get 18. And if we calculate the individual thing expected, okay, control C. Okay, so these are the expected results, and we are getting a chi-square of it. These are the overall values, and if we drag it to that one, uh, I mean to say here we can see expected results are national ratios into length of Minnesota. These are the values. If we calculate the chi-square test of it, then we are getting 18. 18. This 18. Oh, why I missed that conclusion statement? Okay. Yeah, what is this? The landlord, another example I provided. Okay. So here the chi-square test value. Okay, I missed it. Okay, no problem. I will add the conclusion statement. Based on the chi-square test, how you will can see the good. Here it is there. Yeah, significance value is p-value associated with here chi-square. Yeah, here you can chi-square with 0.02. Then it is very strong evidence of rejecting the null value of no. Here I provided. Okay, good fit is something like when we can say it is a good fit. Okay, good fit is if the significance value, that is p-value, if our p-value associated with this chi-square test, okay, if our p-value is associated with chi-square test is 0.002, okay, is 0.002, then there is a very strong evidence of rejecting the null hypothesis. Rejecting the null hypothesis means accepting the alternate hypothesis. That means it is a good fit. It maybe feels you confused, but if you understand the z-score, sorry, the chi-square test properly, here I have chi-square test. Let us see the chi-square test proper example. Square test, chi-square test, you know, analysis, analysis. This is the one. Chi-square test formula example and no, no, simply learn is not good. I don't trust. Investopedia is good. Okay. Here, if you see the explanations are really good here. Here you can see chi-square test. Here they will provide, I guess. Yeah, it can be also a good test the goodness of the fish. Observe the distribution and the theoretical frequency. This is what the formula and what is the goodness of the fish, which takes us a theoretical question. And please go through this. It is really important to know with an example. Let me show you. Uh, where is that one? Okay, no problem. I will provide you that conclusion document to you that will help you to understand in reality. So how to really check the the I mean both is a good fit. Okay, so good fit actually what we say is we have to again calculate the p-value. P-value is not nothing but a significance value. The significance value associated with the chi-square test is 0.02. Then we have to reject the null hypothesis, and then that is what the good fit. Okay, okay. Followed by here, I just provided one more example, small example to find the chi-square with the real thing. Here you can see I calculated the p-value also. Okay, p-value chi-square both we can calculate by using this statistics dot scipy dot stats, where we have chi-square contingency. There is a function is there. Okay, you can use this function. Simply you can pass the frequency tabular. Here earlier we used the what is the frequency tabular we used our national wise, right, national and Minnesota. Accordingly you can use the respective uh, thing whatever we would like to check. We just need to pass that one to our function, and then we can calculate the p-value p and chi-square value. What I told, we have to find the p-value with respect to chi-square value, and if the value is less than 0.02, okay, if it is here it is very clear, it is associated with this, is associated with this, is 0.02, then only we reject the null hypothesis. But here the p-value tells us, here it is 0.0001. Here are not independent, and the condition actually failed. So we cannot estimate the things with the population. Don't confuse. Here I provided the example also. Go through how to calculate the p-value with the chi-square. And also I will find, if I can find some good explanation where you can see the practical example of chi-square test is passed. Here the chi-square is not passed. I'm searching, is there any passing statement? But is this clear? The chi-square overall? Up to now, is this clear? The statistical inference. Is it clear? Is it clear?